Assalamualaikum. Good morning, everyone. Can you see my slides?
Waalaikumsalam. Ya, sudah.
Cuba tengok slide saya ni dalam bentuk slideshow ke apa kejap Okay, slide ke ataupun dalam bentuk ni lagi? PowerPoint.
Dalam bentuk slideshow.
Alright, okay then. Thank you. Kita tunggu lagi 2 minit, okay? Okay, jom kita start boleh?
Okey, doktor.
Berapa orang dah? Alah, nampak 3 je. Tak apalah, kita start lah. So, saya cuba nak habis as much as we can. Lepas tu nanti saya cuba bagi video, the last video, and the end of that video, we have, what is it called? A quiz that will be added to the last time quiz. And then kejap lagi saya sediakan assignment 3 upload dalam Google Classroom, okay? Alright, last time we did stop in here. See if I can get my pen. Okay, so last time we did have discuss about post and get method. Okay, after that we look into head and put. So the head is request the headers only that will return if specified or specific URL were requested with an HTTP GET method. Okay, so for the put method, we need to put uploads new object to the server, completely replace file that exists at the specified URL with the content in the entity body of the post HTTP request message. So if you look carefully in here, these what we call HTTP request message are related to each other. Okay, so if you want to request the head first, you need to get the message from the, you need to get the message from the get first, and then if you want to put something first, okay, then you have to have the request from the post first. Okay, all right, so let me look into example. So the example of HTTP response is usually we start with types of HTTP version. So this is clearly said the versions. Okay, this is the code message, code, which we will look later what is this mean code, and then usually stated that what is the status of the message. So in here it stay okay. So as I said before, it's same as the line of coding that we can clearly understand. Okay, so when it started to request, at what time, and then from what server. Okay, so using OpenSL, so this is the coding. So when it's last modified, the E tag, the exact bytes of range, content length, okay, then content type, usually text and HTML, okay, and then below here is the, what's it called, your HTTP request data. Okay, so this is the header. Right. So what is that? This, if you can still remember here, this one, little guy in here, this number. What does this mean in here? So usually 200 is always for okay, request success, request object letter in this message. 301, move permanently, request object move, new location, specified letter in this message. 400, bad request message is not understood by the server, and this is the famous one that we usually found. 404, not found, okay. Request document not found in the server. And then 505, HTTP versions have not been supported. Okay. So this is the famous one that we usually counter during our daily life or during our access to the internet. Okay. So let's retry the HTTP on the client side. So for example, you want to open gearcsums.edu. Okay, so this is the port number. So this one, okay, by default, it's connecting to the port number 80. So port number. So anything that been typed will be sent to the port number 80 at gearcsums.edu. Okay. Then you got the get the HTTP request. So get this one. Okay, and then it will tell you HTTP 1.1, and then this is the, okay, somehow it's kind of like you got the Gaia CSUMASS in here, and then inside here is what you got, the Kuros one. Kuros underscore Kuros. So by typing this in, okay, you will send this very minimal, okay, GET request to the HTTP server. Next, what they will do is they look at the response message sent by the HTTP server. Usually, you can use Wireshark, okay, to look at the capture HTTP request and respond in here. Okay. All right. So very simple. So you look into the, you type the website that you want to go, and then it will give you the get HTTP and then respond the message. Okay, or look at the message and then respond. Next, okay, if you look back into previous slide, okay, we did have a look into the HTTP is what we call the get or the respond, that interaction with a stateless. Okay, so no motions of multi-step exchange of HTTP message to complete a web transaction. So for example, in here, the client makes a to change to XL and not at all. So for example, okay, in order to maintain the user or server state, okay, we usually use cookies. Have you heard about cookies before? Pernah tak dengar cookies? Hello? Alah, ni saya malas nak kelas online ni, korang tak respon. What is cookies actually means? Any idea? What is cookies actually mean?
Data.
Apa? Tak tahu.
Data.
Data? What type of data? What kind of data? What is it? What kind of data? Cookies, in other words, is the one that is safe or store your history, your web history. Okay. All right. So let me have looks in here. So when you send a request to a server, okay, you log a data of record X. So somehow in server you have your database in here. Okay. So when you request, it store. So it store or save inside a database, the X. And then it says okay for you to go there. And then if anything that has been need to updated in here, it will update into the database. And then it will send back it's to be okay. Okay. Same goes with the, if you need to update the second time, the server will update and then it will say okay. So the problem in here, what happened if you somehow keep requesting the data and your website is somehow broke the link at the T time. Okay. So whenever that you come back for this, how many times? This is 1, 2, 3. If you come back on the 4th time, okay, it will retrieve the one that has not been lost before the T time. Because you already store the cookies in here. It have your history in here. Okay, history. Web browsing. Okay, and then if it lost or it's been lost, okay, and then it's need to unlock back the X and then update the latest one. So the one that is been is this one is the updated cookies. Okay. So what happened if network crash at T? So no need for client or server to track the state of multi-step exchange. Okay. Why? Because HTTP requests are independent on each other. Sekejap saya tutup kipas sejuk pula. Okay. And then you don't need a client or server to recover from a partial complete or never complete a transaction. Because what happened? You have everything's cookie has stores in here. Okay. So what is actually cookies? Okay. Website and client browser use cookies to maintain some states between the transactions. Okay. So there are 4 types of cookies in the web browser. The first one, cookie header line of HTTP response message. Cookie header line in the next HTTP request message. So if you look in here, response message, request message. Cookie file kept on user's host, managed by user browser. Okay. And then back-end database at the website. So usually we are the one who we previously looks into in here. So for example, you type for the first time Unimap at edu.my, and then the next time that you come, when you type just Unimap, and it will automatically appear in your web browser because it have cookies already in there. Okay. So for example, Susan used browsers on laptop, visit specified e-commerce site for the first time. Okay. When initial HTTP requests arrive at the site will create unique ID or what we call cookies. So entry in the back-end database for the ID. Subsequent HTTP requests from Susan to these sites will contain cookie ID value, allowing site to identify Susan. Okay. So it's kind of like you have user in here. Okay. You have your server in here. Okay. You send a request for what website for the first one. It create with the ID, unique ID or what we call cookie. And then it stores in here. Okay. So whenever that you come access again, with the same unique ID, this store identify that this is you. Okay? Identify users. Okay? So let me have a look into here. For example, you want to access to eBay. So eBay in here with unique ID 8734. So you have your own cookie files. You request for a server. Okay? Server, usual HTTP request message. So server in here, you have that, for example, Amazon server, okay, creates ID 1678 for you, okay, for the user. And then this 167 will put into a database, okay, create the tree to database. And then it's respond back, okay, and then it sets a cookie with 1678. So somehow your client database have eBay and Amazon unique ID, okay. Then you request another and then your website or browser will respond back to the server, okay, and then requesting a message with a cookie 1678. So this one will cookie actually be specify the action, okay, where do you want to be accessed. So you access the database and then the server will respond back the HTTP message. So for example, 1 week later, if you want to access the same eBay and the Amazon, okay, so you still send the same message, okay, automatic the browser identify you are using access the same ID number, unique number, and then again the cookie will specify which action and get the access from the back-end database and then return back your message to the client. So what cookie can be used for? First one is authorizations, shopping carts, recommendations, and user session state or web email. So if you can still remember, if you're surfing the browser right now, for example, you are browsing Facebook or Shopee, usually Shopee or the one that I usually, for example, you are browsing, what is it called? For example, sports shoes in the Shopee, okay? Okay, and then it have its unique ID. Somehow, this Shopee unique ID, okay, when it's create a database for you to access, it's provide. Hold on kejap. Hold on kejap. Adik saya telefon. Kejap. All right. Okay. Sorry for that. Now, if you still can now if you encounter this kind of what's it called experience, you access your shoes from Shopee, it create UDID and somehow it store in the database. Okay, but then when you open your Facebook, it suddenly appear or recommended sport shoes that you want, or sport shoes. Okay, all these are actually created based on the Shopee that you have been accessed before. Okay, so that's why, okay, how do you want to keep it in the state? First, you have to have a look at the protocol endpoint. So it's maintain the state at sender and receiver over multiple transaction. And then in message, cookies in HTTP message carry state. Okay, so a site, cookie will permit to learn a lot about you on their site. So if you look in here, learn a lot about you. Okay, third-party persistent cookies, tracking cookies allow common identity cookie value to be tracked across multiple websites. This is when I'm talking about Shopee and Facebook. Okay, if you look carefully in here, if you can still remember the existence of Facebook like 10 years ago, is just nothing about advertising or about shop in the Facebook, right? Facebook is mainly on our social connection, nothing more than that. But since that, when the cookies technologies are being adding, what's it called, advanced, okay, somehow whatever that you access in the Shopee, they give you recommendations to you in the Facebook. Sometimes contohnya bila kadang-kadang saya cakap dengan suami saya macam kita nak kena beli baju baru lah kan, cakap je pun somehow suddenly Facebook track and give recommendation of few dresses or few shirts. Okay, so if you look in here, it's quite horror how everything is that you access in the web browser actually can be tracked or be traces, okay, in terms of multiple of web sites. So this is happen into, pernah tak dengar pasal Facebook before they change their company to Meta? Facebook in the last 2-3 years there has been sued in America. Pernah tak dengar kes tu? Do you know why? Because what they are doing actually is that everything that they took from the cookies server or database server, they use inside the Facebook. So somehow this kind of cookies is actually breach your data protection. Okay, breach of your data protection. So we look later how it's breach your data protection. Okay, so shall we try that? Okay, for example, you want to access the New York Times web page. Okay, so this is you request, okay, and then the server will reply. So you get the base HTML file from newyorktimes.com. Okay, once you got that, okay, somehow they have adx.com, another server in here that will put advertising in here. Advertising. Okay, so that is how they do actually. And then replace or add on the advertising into the web page. Add on. Okay, once that, it will give you a New York or display the request page, okay, New York Times with the embedded advertising display. Okay, so how they track your browsing behavior? So for example, you request newyorktimes.com, you go to specific page, for example, sports. Okay, you get, and then it will identify your unique ID number. So 1634 spot, and then this unique what's it called? Date access. Okay. And then when the server want to reply back to you, it reply, and then it set the cookie 1634, and then somehow in your database, web server database behind the back end, it will save as 1634. Okay. So this is what we call the first party cookie. Okay. From website you choose to visit, provide the base HTML file. Okay. And then you get the New York Times font. Okay. Hold on. Check. Bateri saya. Check. Bateri saya. Okay. So you have a New York Times spot. You've got another unique ID. Okay. And then it will store inside this adx.com. Okay. And then we reply and then set the cookies adx7493. So somehow in here, if you can see, there's a 2 cookies IDs. Okay. So this one is what we call the third party cookies from website you did not choose to visit. Okay. But then it's embedded into your website. Okay. And then if you want to go with the socks.com, okay, so advertising adx.com will go to this particular server, Shopee, I would say, server of shop. Okay. So these 2 requests, okay, you got the HTTP GET and then HTTP reply. Okay. And then it will again give the server another cookies with 7493. So you got the socks.com in here. Okay. And then it's being added into the database the next day of the service. Reply back, and then you got cookies with 7493. Okay. So this is how the ADX will track your web browsing oversight with ADX advertising, and then can return targeted advertising based on the browsing history. So that's why when you go to, for example, Facebook, and then the Facebook actually retrieve your browsing from the advertising. Okay, so if you go to the socks.com and somehow inside your Facebook, you will look into the advertising about socks. So write ADS on socks. Okay. All right. So now you want to go to the same browsers the next day, okay? And if you look in here, all the databases actually have have stored your unique ID of access. Okay, have stored unique ID of your access. So again, this time it's followed with the cookie number. You get to set the cookies, okay? And then New York Times add on, okay? The New York Times cookies unique ID, okay? Request for ADX, reply and then set again, okay? And then it will return the address advertising for the source, okay? So cookie can be used to track user behavior on given website. So this is first party cookies, and then tracks user behavior across multiple websites, third party cookies, without user ever choosing to visit the tracker site. So this is very, very have to be careful when you are trying to access to the website. So tracking may be invisible to user, but rather than display advertising trigger the HTTP get to tracker could be the invisible link. So third-party tracking via cookies, what you have to do, you have to disable by default in Firefox or Safari browser, and then you have to be disabled in Chrome browser in 2023. So why it have in here? Okay, why I said that cookies is rated with the data protection. Natural person may be associated with online identifiers such as Internet Protocol address, cookie identifier, or other identifier. This may lead to trace which in particular when combined with unique identifiers and other information received by the server may be used to create profiles of natural persons and identify them. Okay. So when cookies can identify individuals, cookies are considered as a personal data, subject to GDPR personal of data regulation on each country. Okay. So that's why if you come to a new website, okay, you will come into something like this. This site use cookies and give you control over what you want to activate. When you come to this, you have the control either to accept. If you accept, it means you are allowed others' website or third-party cookies to access your data protection. Okay. If you have a deny, then you are deny everything, and personalize. Actually, you can personalize everything. So make sure when you access to the web browser, okay, pay particular attention to this particular pop-up message, which actually allow you to control whether we can allow you to control your cookies to be stored or not. Because it's not, of course, the good thing is that if you use the cookies, it can remember everything that you can't remember. I do use cookie, especially when related with teachings. But if for shopping or something others that not related with shopping, I try to deny it all, because once you accept the cookies for all any types of website, they will use your personal data, everything's in there, and then it will pass across all the parties, all the third parties cookie, and pass to different types of website. So be careful when you want to access cookies, in any particular website. So web cache. So next one, if web cache satisfies client request without involving the origin server. Kejap saya tengok berapa. Okay. So user configure browser to a point or to a local web cache. Okay. So you got origin and then web cache, and then you have a client and client over here. So browser sends all HTTP requests. So if object in cache, cache returns objects to client. Else, cache requests object from the origin server, cache receives an object, then returns objects to the client. Okay. So if it doesn't have anything that been stored in here, so it's actually written with cookies. So if you have a cookies before that has been saved, this cookie actually been cached from the web cache. Okay. If it's your first time, usually it requests for the origin server. Okay. If your access is for the second time or more than once, and then it usually goes up to until the web cache. So this is where you store all your previous web browser. The same thing happen, for example, if you want to buy a flight ticket, okay? Usually, if you request, for example, we take in Asia, okay? You want to travel from Alostar, AOS to Kuala Lumpur. The first time that you type the origins, Alostar, and the destination Kuala Lumpur, okay, it will display, the table and the fees and everything. But the second day, if you want to travel there, if you look carefully into your website, AirAsia, or any app, it will automatic catch you the previous history of the research or the search of your flight. And usually when you get your information from the cache, it's kind like I would say it will save the history as long as it can, and then somehow, for example, like a web cache. Kejap saya tengok soalan. Kenapa? Kejap Kiran. Somehow, it will store the price, especially the price. It will keep updating the price as as not as low. It can be as low as it can, but sometimes when you go to after next day, it will give you high price. That's why, for example, myself, if I want to buy a flight ticket, I usually clean up my cache first, so that the server don't understand or do not have the authority to find my search. And then when I search again, you will got a different price of flight ticket. Okay? Because you did manage to clean up the cache for that one. Okay, Kiran, what's the questions?
Saya tersilap tekan, Doktor. Sorry.
All right. Okay. Okay. So that's my tips. Okay, if you want to buy flight ticket or anything, just clear up your web cache first, and then see if you have changes of flight ticket price after that. Okay. So web cache, or what we call the proxy server, acts as both client and server. Okay. Server for original requesting client and client to origin server. Server tell cache about objects allowable catching in the response header. So for example, you've got cache control and no cache in here. And why is it the web caching? Reduce response time for client to request. So because cache is closer to the client. Reduce traffic on institution access link. So this is usually this is usually on university. Sekejap saya tu tak kipas. Cucuk. Okay. Internet is dense with a cache. Okay. Enables poor content provider to more effectively deliver content. Oh my God. Okay. So caching example. For example, you have 1.54 access link in here. RTT to router to server. Router to server in here is 2 seconds. What object size? For example, you want to send 100k bits. Sorry. Alhamdulillah. Average request rate from a browser to origin server is 15 seconds. Okay. Average data rate to browser is 1.50 megabits per second. So, you got your access utilization 0.97. Sorry guys. Sorry ni tak boleh sejuk sangat. Okay. But this will require a large QE delays at high utilization. Okay. LAN utilization 0.0015. Okay. So end-to-end delay, you got internet delay plus access link delay plus LAN delay. Okay. You got 2 seconds in here plus minutes and plus second. Okay. So somehow, if you look in here, when we're talking about minutes in here, this is going to be too long. Okay. So for example, okay, the first option that you can do is buy a faster access link. Okay, you increase the access link with 154 megabits per second. And then you got access link utilization 0.0097. And then this one will increase to millisecond. Somehow, if you use this kind of option, okay, you need to buy, the cost will be increased because the fastest access link will be very expensive. Okay. Now, what you have to do, you install a web cache. Again, your access link 1.54. You install the web cache in here. Okay. So web cache is much more cheaper. And then you can look into what is the LAN utilization, access utilization, and average end-to-end delay. Okay. All right. So how do you want to calculate the access utilization? So suppose that cache hit rate as 0.4. So 40% request server by cache with low milliseconds of delay. 60% request certified at origin. So rate to browser over access link, okay, 0.6 times 1.5 megabits per second. So 1 megabits per second in here is this one, average data to browser, okay? So you got 0.9 megabits per second. Access link utilization, okay, 0.9 divided by 1.54. So what is 1.54 just now? Access link rate. Okay. 0.58 means low milliseconds queuing delay at the access link. Ada orang kat tengah ke? Okay. Saya ni sejuk saya macam sesama sikit. Okay, so average end-to-end delay, so 0.6 times delay from the origin server, okay, plus 0.4 times delay when certified at cache. Sekejap, Allah. Tadi saya dah tutup, sebab saya pergi buka pula. Kipas. So 0.6 times 2.01, okay, plus 0.4 times milliseconds, and then roughly you got how many of 1.2 second in here. Okay, so if it looks in here, it's much more faster if you're using access link, all right, or cheaper access link. Okay, browser cache for the conditional get in here. You don't need to send an object if a browser has up-to-date cache version. So no object transmission delay or use of a network resources. Okay. Specified data of browser cache copy in the HTTP request. So for example, in here, if modified since, and then the server will put when is the last bins are modified. And then the server will respond contains no object if browser cache copy is up to date. Okay, so the server in here will respond whether it's been the cache is been modified or not. So you request message, okay, object not modified before, okay, before date what date. So server will respond back there's no modification has been updated. Okay. And then if there's a modifications later on, okay, it will request again after what kind of the date, and then respond with everything is okay. Oh my God. Okay. Now, previously, all these things we learned into the HTTP 1.0, 1.1. Okay, now we look into HTTP 2. The goal of HTTP 2.0 is to decrease delay in a multi-object HTTP request. So previously, HTTP 1.1 it introduced multiple pipeline gaps over single TCP connection. So the server will respond in order, first in, first out, or first come, first serve, to get response. Okay. With LCFS, small object may have to wait for the transmissions, head of line blocking behind a large object. So loss recovery, retransmitting lost TCP statement, stall objects transmission. Okay. So HTTP2, okay, increase the flexibility at server in sending objects to the client. So method status codes, most header fields are unchanged from the HTTP 1.1. Transmission order of requested object based on the client's specified object priority, not necessarily first come, first serve. So push unrequested objects to the client, divides the object into frames, schedule frames to mitigate hall blocking. So for example in here, client requests one large object, for example, video file, and 3 small objects. Okay. So this is a video. This is other little things. Okay. So basically in the 1.1, you will request your object and then return back and then you get what you want. Okay, so O1, O2, O3, O4. So objects deliver in order request. Okay. O3, O2, O3, O4, and then we have to wait behind O1. And if you look in here, O1 in here is very large of data. Okay. Meanwhile, these little 3 things is quite small. So they have to wait for a large video or large data to be transferred completely before they can move or they can forward to the client. So what the HTTP2 do is that object is divided into frames, frame transmission interleave. So if you look in here, O2 right now has been divided into frame. Okay. Since most of the frames are in the almost same size, okay, you can send, okay, first frames of O2, frame 1, O1, sorry, and you send O2, and then you send O3, and then you send O4, okay? And then this one, O3, is actually F1, O3, because you divided again this one into 2 frames. Okay? And then after that, okay, you set another frames of F2, 0, 1. And then this one become the F2, 0, 3. So this one is already complete. Okay, and after that, forward all the other frames of O2. So O2, O3, and O4 will be delivered quickly, and then O1 will be slightly delayed. Well, assuming that the data, the video file is large, we assuming that it might be late. Okay, so now we come to HTTP 3.0. So HTTP 2 over single TCP connections means recover from the packet loss, still stall all objects transmission. As in HTTP 1.1, browser have initiative to open multiple parallel TCP connection to reduce tailing, increase overall throughput. Okay. No security over vanilla TCP connection. Okay. HTTP 3 will add security, per object error and congestion control, more pipelining over UDP, more on HTTP 3 in transport layer. Okay. Right, so that's up, finish with the web and HTTP. Awak boleh lagi ke ni? We got another 1 more minute. Baru pukul 9. Sekejap, saya tengok saya punya ni. Boleh lagi ke semua?
Masih hidup, doktor.
Boleh, doktor, boleh.
Masih hidup. Sekejap, saya tengok. Saya cuba, okay. Okay, saya cuba habis email, SMTP and AP. Lepas tu the rest is kita cuba bagi video, okay? Friday kan? Semua dekat rumah dah ke? Semua orang kat rumah dah ke?
Ya, doktor.
Ya?
Rasa dia tak balik ikut.
Oh, ya. Okay. Sekejap, berapa orang masuk kelas saya ni? Sikitnya. Itu sebab saya malas nak masuk online. Senyap je. Okay. Next one. We look into email, SMTP and IMAP. So, emails, there are 3 major components. You got the user agent, so this is like you, okay, and then you got mail server. Okay, so mail server in here, you got your mailbox in there, and then the outgoing message queue, which email that you want to be queued, and then you got the protocol, which is simple mail transfer protocol. Okay. So user agent, mail reader, which is you are responsible for composing, editing, reading mail message, and then example, Outlook or iPhone mail client, and then you look into outgoing, incoming message stored in the server. Okay. Mail server, okay, it contains incoming message for the user, okay, message queue for outgoing to be sent mail message, and then protocol. Between mail server to send email message, you have the client that's sending the mail server and the server that receiving the mail server. So for example in here, saya cuba hantar mail. So I am here. So we are in Unimap in here. So we have our own mail server, and then somehow in here I want to send a mail server somehow in UK. Okay, so for example, my SV in here in UK. So in order to send in here, they got another mail server in here. And then between this server, we have the protocol, the one that will do the job for our exchange email. Okay. So what usually the SMTP do is that, so this is us. This is somehow a server, okay. Again, it uses a TCP, okay. And then this one is connecting to port 25. So direct transfer, sending server, so it's acting like a client to receiving server, okay. There are 3 phases of transfer. The first one, you got the handshaking, okay. Again, when you are talking about TCP, you always have the handshaking. Okay. So you need to initiate first the TCP connections. From here to here is the RTT, and then it's been connected. Okay. Handshaking, you are greeting. Okay. You send back hello. And then again, this one is server send back the hello. Okay. And then you transfer the message. Okay. Depends on how long or how large the data. How long or large the data. Okay. And then the SMTP closure. Common response interaction like HTTP, SC2 code text, and the response will be status code and phrase. Very simple. So, for example in here, Alice used UA to compose, okay, email message to Bob or to bob@samschool.edu.my, okay. And then Alice UA sends
user agent message to her mail server using SMTP, and then the message will place in the queue. Okay. Then client side of SMTP at mail server open TCP connection with bulk mails. So this is TCP connection. Okay. And then SMT client send Alice message over the TCP's connection. And then bulk mail server place the message in the bulk mail box, and then bulk his user agent to read the message. Okay. So sample interactions. So you want to access to hamburger.edu. This is your server. This is your TCP connections number. Okay, client, say back this one, send response, crips.france, so this is somehow in France, and then server say, hello, crips.france, pleased to meet you. Okay, mail from alias crip.france, okay, 250, okay, alias crip from sender, okay. Okay, receipt to Bob, hamburger.edu, Hamburg, and then 250 Bob alias Hamburg.edu, recipient, okay. The data, enter mail, and with dot on the line by itself, okay. Usually the email in here, if you didn't put the dot in here, somehow the dot in here play important roles, especially on the sending the email, because dot in here is the one showing that there's no other data after that. Okay. All right. Okay. Then the client send the data, and then message accepted for delivery. Quick, hamburg.edu, closing the connection. All right. So, comparison with HTTP. HTTP, it will have a client pool. SMTP will be client push. Okay. Both have AC2 command, response interaction and status code. HTTP, each object encapsulate in its own response message. And then SMTP, multiple objects sends in multi-part message. So SMTP use persistent connection, require message, header and body to be in 7-bit SC code, use clear RF, okay, to determine the end of the message. Right? So message usually exchange format, defined in RFC 5321, define syntax for email message, like HTML defined syntax web document. So for example, you have the header. So this is where you come your to, from, subject. Okay, this line within the body of the email are different from the SMT mail from or recipient to commands. Okay, you have the blank line and then you have the body. So if you look the email as how you send the email right now, there's the purpose why you need to have this particular header and then this particular body. This format of email is due because to support the SMTP protocol. Okay. Okay. Again, this is same. Okay. You see. So SMTP delivers storage of email message to the receiver server. Mail Access Protocol, IMAP, Internet Mail Access Protocol. Message store on server. Provide retrieval, deletion folder of stored message on server. Okay. So this one, if you want to delete the email or undo, I'm not sure about. If you look into Gmail, for example, you accidentally send the email but you didn't finish writing up the email, somehow in Gmail you can have the undo message before it's fully transfer or fully sending to your receiver. If you look into your Gmail, cuba try nanti among yourself. You send email and then somehow in here there's an undo button. undo message. Okay, so it's mean that it will not send the email yet. Okay, because you managed to undo it, but you need to have a look at it because it's very quickly and can be missed out. Okay, HTTP, Gmail, Hotmail, Yahoo provide a web-based interface on top of SMTP to send and IMP or POP to retrieve the email message. So these are Gmail, Hotmail, the one that you see in your Gmails is mostly into like a web-based interface. Okay? Alright. Boleh lagi ke? Kejap, saya cuba try. What time is it? Baru 9 suku. Sekejap, saya tengok domain name system. Banyak tak? Nak kejap ke 2 minit? Kalau awak dah nak habis semua. DNS quite banyak lah. Boleh saya bagi ni video dekat awak?
Boleh doktor.
Boleh saja. DNS quite ni. Okay? Nanti saya bagi DNS, P2P, video streaming and socket. Okay, any other questions before we go into... Tak banyak dah sebenarnya. Okay. Kejap, saya bagi attendance. Kejap ya. Okay. Apa tak? Buka.
Boleh buka doktor.
Okay. Okay, kalau dah habis, I'll see you next week. Cuti hari Isnin ni, saya akan bagi assignment dalam masa few minutes. Nanti tengok assignment ni and then have a look into the videos that I will upload later on. Boleh ke?
Boleh doktor.
Boleh tu.
Boleh doktor.
Okay. Okay, goodbye everyone.
Thank you, Doctor.